Hello and welcome to another episode of Black Hole Battles game development here on Let's Code Physics. I'm still in the middle of setting up the control theory based controls for our enemy ship. Last time we were able to get this list of trajectories generated that the ship is going to consider taking. I do want to show one change that I made to the make trajectory subroutine before we get to the stuff I added today. I was thinking about it and I realized that having the trajectory point spaced by the time.delta time assumes that the ship is going to zip over from its current point to its goal point within 4 frames of the game. And that's probably not likely the case. Based on the ship's speed, moving ahead 4 frames is either very short distance, or that's assuming the ship is going way faster than it actually is. So what I've done instead is I've added in this calculation of the distance to the goal. So this is the goal location minus the start location and taking the magnitude of that relative position vector. And then, of course, the ship is not traveling in a straight line like this vector would suppose. So I'm adding in a little fudge factor of 10% here to allow for the curvature of the trajectory. I'll probably need to increase that. I'll play around with that once I've actually got the thing completed and can visualize it in the preview. And then here we're calculating the amount of time that it would take for the ship to go that distance based on its current speed. So down here we've got a calculation of the ship's current speed. The ship might be able to go faster than that if it's not going at its maximum speed right now. But otherwise, it's a pretty good estimate of the amount of time it'll take to get there. And so that's how I've calculated goal time here now. The other change that I've made here is instead of having a fixed 4 points in the trajectory, I've made it to where we can have an arbitrary number of points in the trajectory as long as it's within the goal time. So ideally that gets us to the goal point, or at least pretty close to it, depending on how good this fudge factor is. And so this goal time here, basically it's controlling this loop and saying that as long as the time of the current point that you're considering is less than or equal to the goal time, keep going. And so of course we're adding, we are going frame by frame in this case. We are considering 1 frame at a time. I could probably increase that to improve the performance. If the game runs slowly, that's one of the things I'll take a look at. Increase to improve performance. There we go. Little note for my future self. But other than that, the rest of the calculation is the same. We're still calculating the current trajectory point in the same way. So that's good that that we've got that a little bit more versatile now. Let's see. Let's go back up here. All right, so that's the change I made to the trajectory generator. The next thing I want to talk about is the next chunk that I've added, which is evaluation of the trajectory cost. So in control theory, one of the things you can do is you can have your device, your ship in this case, consider multiple trajectories and select it based on whichever one has the lowest cost. And that might be the lowest danger, the most in efficiency, high cost would be high danger. You want to, You want to select it with the lowest cost, which means the lowest danger, highest efficiency, etc. So our inverse relationships mess with my head some days. So what I've done here is I've set up several cost factors. So this is the weighting for each of these costs. So for example, the first cost we need to consider is, does this trajectory cause our ship to go into a black hole? That's pretty important because that is game over for the enemy ship. So that cost factor is relatively high. I've got it at 1,000 right now. These scalings are temporary. I probably need to change them, based on how the math actually works out. These are good starting values, but this is 2 order of magnitudes larger than the others. The others I've weighted all about equally. This one is the cost of how close does this trajectory bring our ship to a black hole. This next one is the cost of giving the player advantage over the enemy ship. So this is, and I think we've set this up in a previous video, is the enemy ship caught in between the player ship and a black hole. And then we've got the reverse of does this trajectory give me advantage over the player? And so this is whether the player ship ends up in between a black hole and the enemy ship. I have that calculation set up in our previous enemy controls subroutine, so I'm going to take a little bit more time off camera to copy that over and make sure I've got all the angle and position calculations set up correctly before I add that in. So today we're just going to take a look at these first two costs, whether we end up in the black hole and how close we end up to the black hole. So to evaluate the costs, we're going to keep track of which one is the best trajectory. So out of all those trajectories we generated up above, the best one, the one with the lowest cost, is going to end up stored in this list here. And the best cost is going to be the lowest. So that's going to be at most 1,000. Or yeah, because we're not gonna take any trajectories that are going to take us to a black hole. So I've gone ahead and taken this as 1,000 times the cost to fall into a black hole. So I've already got 1,000 times 1,000. So that's 1,000,000. Yeah. It's 3 zeros plus 3 zeros make 6 zeros is 1,000,000. Plus our cost to the closest black hole, plus our cost to the player advantage, plus our cost to our advantage. So this is a really high number, right? This is 1,000,000 and some change. So we are not going to be selecting any trajectories that are higher than this. If we're ever in a situation where we are higher than that, well, then I suppose we're in a spot of trouble. I might need to increase this number even further, but I doubt I'll need to do that. I sincerely doubt I'll need to do that. Let's see. So here, we're evaluating each of those trajectories. So this list, trajectories, stores all of the trajectories that we generated earlier. And so each one that we're considering, we're calling traj in this for each loop. And so we're starting off that traj's cost with a 0. And then we're just going to evaluate each point within that loop. And so the first thing we're going to do is we're going to check for whether this point leads us into a black hole. And I learned a neat trick to check that. In Unity, there's this nice function called physics.overlapSphere. What this does is it takes a single point, so it takes the point that you're interested in, and it forms a sphere around that point of whatever radius you give it. In this case, we're giving it a radius of the ship's size, because we want to know whether the ship edge is going to touch the edge of a black hole. And what this command does is it looks for any colliders, any objects that have a collider attached to them within this sphere, so within the radius of this point. And it's going to store all of those in this list, or I guess it's an array, excuse me. It's going to store all of them in this array hit colliders. So these are all of the colliders that got hit by the overlap sphere. Name making sense? Good. If you don't like it, take it up with the Unity folks, because this is the name they use in their sample code. So what we'll do next is we're going to look at each collider that is in that list. So each game object that was collided with. Now, so far in the game, the only game objects we have are black holes and the enemy and the player ship. We've also got our IM, our Isiomatter, the currency. Actually, yes, I guess those do have colliders, don't they? Except I think I have those set as triggers. Either way, the only thing this thing is going to find right now is black holes. But later on, when we add asteroids, when we add, friendly ships, when we add, other stuff to the game, we're going to need to be able to tell whether this is a black hole. So here we're checking for whether that collider's parent is tagged with black hole. So this is where we evaluate, is there a black hole within the sphere? If there is, then we add to the cost in black hole. My cost has immediately gone up by 1,000. It's immediately become unfavorable and will hopefully be rejected unless the only winning move is to head into a black hole. So that immediately makes the cost high. The next thing we're going to look at is whether this point leads us close to a black hole, or rather, how close does this point lead the ship to a black hole? Now, obviously, if we were led to a black hole, if we were led into a black hole, then we don't need to worry about this, because this is already a bad trajectory. We're already too close to a black hole. So what we're doing here is we're checking whether my cost is less than cost in black hole. The reason I'm doing that is I don't want to have to run over this loop over and over again, just because, excuse me, I don't want to have to run over this over and over again, just to check whether we get quote-unquote too close to a black hole when we're obviously already too close to a black hole from here. And so what we do is we look for, we're looking for whether we've seen any black holes yet. So we're setting no black holes equal to true, meaning we haven't seen any black holes yet. Let me put a note here, haven't seen any black holes yet. And basically that will become false whenever we find a black hole. And so here we're going along with, actually it occurs to me I have a little bit of a mistake here because I'm referencing point here, but it doesn't know. Oh no, it is in that loop. It is in that loop. Okay, yeah, that loop hasn't closed up yet. Okay, so I'm still in, let me back up a second. I'm still in this for each vector 2 points. So I'm still looking at that particular point. I haven't left that point yet. So now what I'm doing is I'm changing my search radius. So now instead of having a search radius of the ship size, we're going to look at 2 times the ship size. And so again, we're going to run our physics.overlap sphere, only now we've got this new variable search radius. Instead of it being fixed to the ship size, we're going with the search radius here. And so what we're doing is, again, we're checking for whether there's a black hole within that sphere. Only now, it's not in quite as bad of a danger zone because it's not in immediate contact with the ship. It's some distance away from where the ship is. And so basically, if we find a black hole within that sphere, then we set no black holes equal to false. That's going to mean that this is going to be our last time around this loop. And we're going to increase the cost by the cost to the black hole, cost being close to the black hole, so that's our currently 10, divided by the distance to the black hole squared. So that's our search radius squared. And I chose to square it because the gravitational force is squared, so it makes sense to me to weight this in terms of the distance squared. So I could be wrong about that. There might be a better way to do that, but just because that's going to be the force on the ship from the black hole, then that seems to be reasonable. Now, of course, it could be that this point is in between 2 black holes whose forces pretty much cancel out. So what I could do is I could make this a little more complicated and calculate the force at this point created by the black holes. I guess that would be the gravitational field if there's no ship there, but I could just use a ship mass. But I think I'm going to stick with this for now because this is a little bit simpler computationally, I think, unless this physics overlap sphere is more computationally intensive than I think it is. But I'm going to leave it this way just because obviously, being farther away from any black holes is going to be better than being in between 2 black holes, although I could adjust that later on. We'll see how the thing ends up behaving and see if we need to adjust it. And then within each go of the loop, we're going to increase the search radius by the ship size again. So we're going from, from 2 times ship radius to 3 times ship radius to 4 times ship radius. And eventually we are going to find a black hole, right? Unless we've accidentally created a level without any black holes, which I don't think it's going to be possible. We're eventually going to find a black hole. And so that's the cost calculations I currently have in effect. The next things that I need to add, so the things we'll look at next video, is adding the cost of giving the player advantage in our trajectory and the cost of us having advantage. So I guess that's actually a benefit. So this is sort of like an inverse cost. So actually maybe that'll be like subtracting 10 off of it or something like that. I'm not sure. I have to figure out how to work in a cost for a good thing. But I'll also leave you with this last piece. We've already got our trajectory selector up and running. So we're going to have, if the current trajectory's cost is less than the best cost, then we'll store that trajectory in best trajectory, and we'll update the calculation of my cost, which needs a semicolon. I'm glad I went to this line and was able to see that. And actually, now that I think about it, I'm going to add these in later because the enemy ship to player ship interaction can be a bit complicated to test, and I'd really rather get this thing running sooner rather than later so that I can visualize it and see whether there's any issues with what I have so far. So actually, the next thing we're going to do, my apologies for being misleading, the next thing we're going to do is plan the execution of the trajectories. This is where we're actually going to bring in the ship controls and determine what its thrusting and rotational patterns are going to be. So that'll be what we look at on our next video. Thank you so much for watching. I will see you next time. Bye-bye.